Hello, everybody, and welcome to today's webinar on AWS Backup, a centralized backup service from AWS, supporting AWS resources. My name is Jody Kirk. I'm joined by Mas Kubo. Mas is a product manager here on the AWS Backup team, and I'm on the storage business development team. Let's dive into the content. So let's start first with a historical look at backup models. So there are multiple models for backing up data. Historically, backup was done on premises within a corporate data center utilizing backup software, media servers, and dedicated backup appliances. For long-term retention, data was typically archived on tape and taken off-site via typically a third-party service. And this model is still widely employed today. So with the onset of cloud, a new model emerged whereby the cloud could be utilized as a backup target with data access to the cloud enabled by the use of a gateway device, such as the AWS Storage Gateway, or by native cloud connectors offered by most backup vendors. This allowed customers the opportunity to eliminate backup storage appliances in favor of remote, more scalable cloud resources as an alternative. We're also seeing a third model, a cloud native model, whereby customers running workloads in the cloud have a need to back up those resources just like they did in their corporate data centers. They need to manage backup operations and ensure adherence with compliance requirements. Cloud native data protection has been in place for many years, offered as a feature in many cloud native services, including those offered by AWS. But it's been sort of a service-centric function. So, which created some new challenges for customers who are protecting their data within the AWS cloud. So today what we're going to do is we're going to introduce you to a new service from AWS called AWS Backup and discuss ways this new service can assist in some of the challenges of protecting your data in the AWS cloud. So talking with customers regarding their data protection challenges in the cloud native model, a few trends begin to emerge. While the data protection features exist in AWS, there's a need to perform backup operations on a per service basis. Also, when managing backup operations for multiple services, there's no central way to monitor status, to understand backup progress, completion, or any errors that may have occurred. When performing backup audits, there's no central mechanism for aggregating the backup logs across services, making audit compliance a highly manual process. And there's also no way to enforce corporate backup policy across services in an automated way, leading to inconsistencies across the organization in terms of the way data is backed up. So as a result, customers often resort to scripts and manual processes in order to meet their business and regulatory compliance requirements. This has been consistent feedback from customers regarding their use of AWS services. So as a result, we launched AWS Backup, which is a service that's used to centrally manage and automate backups across AWS services. It's backing up services both in the cloud within AWS and also extends to on-premises backups through the use of the storage gateway. So let's dive into some of the features of AWS Backup. AWS Backup provides centralized backup management for resources on the AWS platform. It introduces a centralized backup console and set of APIs that offers backup scheduling, retention management, and backup monitoring. AWS Backup enables the creation of central backup policies that can be uniformly utilized across AWS services to ensure corporate-level backup compliance standards are met. This capability allows a more effective way to enforce policy, conduct audits, and ensure compliance with regulatory requirements. On top of that, AWS Backup has been designed to be cost-effective and easy to use. Let's dive into some of the features of AWS Backup. AWS Backup is built around a backup plan or set of rules that define the backup attributes. The attributes include items such as when to start the backups, the duration of the backup window, the type of backup, full or incremental, and the retention period. One of the core capabilities of AWS Backup is the ability to utilize tags to affect the backup of resources you'd like to protect. Once a backup plan is created, you can assign AWS resources such as EBS volumes or EFS file systems to the backup plan, and AWS Backup will start automatically backing up these resources and managing backup retention on your behalf according to the backup plan you create. You can use AWS Backup Central Console to view what AWS resources are being protected and monitor backup and restore activity. And you can use AWS Backup to restore from a backup, but creating a new resource for that restore. For services that support AWS Backup's advanced features, such as EFS, there are additional capabilities that are enabled. These advanced features include the ability to lifecycle backups to cold storage, the ability to employ a secondary level of encryption for backup data, and the ability to back up to an independent storage class from the source data. AWS Backup's integration with AWS services comes in two forms. First, AWS Backup is integrating with existing backup capabilities for AWS services that already have data protection built in. Examples of these include EBS, RDS, DynamoDB, and the AWS Storage Gateway Volume Edition. And this integration happens via AWS Backup's controller, which provides automated scheduling, lifecycle policies, and monitoring. These services with existing backup functionality write an agent to integrate with AWS Backup's controller to enable a common centralized backup manager. Second, services that do not already have backup functionality, such as EFS, are responsible for building a service-specific agent that extracts data from the service for backups and creates new resources from the backup or restores. This second model is what enables the advanced features shown under EFS in the table. In the fullness of time, you can expect this matrix will expand both horizontally and vertically as we add additional services and extend functionality to existing services. Let's take a look at a before and after example of how a customer may have protected multiple applications running in AWS. In application A, there are a number of resources that the application utilizes to operate. To protect application A data, an operator would need to go to each of the services supporting that application, either via API or through the console, in order to initiate those backup processes. When the application data is restored, a reverse process would need to take place to restore the application data to its prior state. Multiply this by the quantity of applications that a customer has deployed, and the complexity increases. AWS Backup is built around the concept of a backup plan that identifies when to begin a backup process, the backup window, the type of backup, the backup frequency, and the retention policy for those backups. These rules are wrapped into a policy called a backup plan. Once the plan is created, you can label the plan. In this example, we've labeled the backup plan mission critical. Now, when you go into a service and create a resource, such as an RDS volume, you can tag that resource with a backup plan label, and that resource will automatically begin being backed up per the attributes defined in your backup plan. The creator of the resource does not need to interface with the AWS Backup Console or APIs to enable the backup plan to take effect. This is done via the service and through the use of tagging. This provides for consistency in the backup of resources to a company-defined standard, making compliance easier to accomplish. So now, instead of managing multiple service level operations to support data protection of an application, you can tag or assign resources to a backup plan and have them protected in a consistent manner with the same window at the same frequency. This provides the ability to protect application data by performing coordinated backups across a group of resources in disparate services. You can also monitor the progress of these operations from a central console. AWS Backup can be managed via the AWS console. It's listed under storage services, also via the AWS Backup API, and is supported by the AWS SDK. So tagging. You can assign your AWS resources to backup plans using tags or by assigning the resources ARNs or ARN prefix directly to the backup plan using the AWS Backup Management console or AWS Backup APIs. To use tags for resource assignment, first list the appropriate assignment tags in the backup plan. Then when you tag an AWS resource with one of those tags, it will be automatically assigned to that backup plan, and backups will start ensuing per the plan. So for example, let's say you created a backup plan called Mission Critical. That backup plan performs backups on 4-hour intervals across multiple services. As a backup administrator, I create this policy, and if I have a team administering the application, inform them that this backup plan has been created. Now, anybody who is creating resources related to the Mission Critical application could tag those resources as they are creating them so that the Mission Critical backup plan will be applied. This will be done within the service where the provisioning is taking place, so the user does not have to interface with AWS Backup Console or API. This model is important for organizations who have a separation of duties between those who administer applications and those who perform backups. Within AWS Backup, we have the notion of recovery points. Recovery points represent a specific backup from a specific resource in a specific service. For example, a recovery point may be a backup of an EFS file system with a specific file system ID backed up on a specific date. You can also view the status of that backup. When restoring from a recovery point, you select the recovery point you wish to restore from. AWS Backup will then take you through a step-by-step process to configure the backup or restore the backup according to the recovery requirements of that specific service. In the EFS example, you'd select whether you wanted AWS Backup to restore to a new file system instance or to a directory on the current file system from which the backup was taken. Status of the restore operation can be viewed in the AWS Backup console. You can also track logs in CloudTrail and receive SNS notifications on events that are taking place within AWS Backup once you configure SNS for that service. Backup vaults are containers managed by AWS Backup where your backups resources are stored and managed. When services are protected using AWS Backup, the resources assume the security posture of AWS Backup. So for example, if you have a role definition, IAM role definition within AWS Backup, somebody can take action on those backup resources per the role definition. Now, if you go into let's say you have an EBS snapshot and you go into the EBS console, you'll still be able to see that resource from the EBS console, but you may not be able to take action unless you have the credentials to take action as defined within AWS Backup. So this allows customers to restrict access to specified resources to prevent accidental or malicious deletion of backups. So all backups support encryption using KMS encryption keys. AWS Backup also introduces independent encryption for services that utilize AWS Backup as the backup storage, at this time only EFS. This provides the ability to encrypt backups using a separate KMS key, providing an extra layer of security. Users can also configure IAM to control access to AWS Backup APIs. And AWS Backup also has the concept of the backup vault, which we just discussed, and you can assign access policies at the backup vault level, specifying who has access to the backup vault and what actions that they can take against the resources that reside within the backup vault. Let's talk a little bit about pricing. So pricing for AWS Backup is very straightforward. For services other than EFS, where AWS Backup is providing orchestration and policy-based management of backup activities, you only pay for the storage you utilize in your backup activity. So if you're performing EBS snapshots today, for example, and incurring expenses for storing those snapshots, you would not incur any additional charges when using AWS Backup. In fact, your AWS invoice will continue to list EBS snapshots as the line item with associated storage spend. Same is true for EBS, RDS, DynamoDB, and Storage Gateway. There will be no additional charge for using AWS Backup. For EFS, the situation's even better because EFS is using AWS Backup as the backup storage. The cost is significantly lower than what you would be spending today if you were doing backups of EFS within EFS. Additionally, since EFS supports AWS Backup Lifecycle Management, you can set a policy to migrate backups to cold storage after a specific period of time to further economize your backup spend. At launch, AWS Backup has regional availability in US East 1 and 2, US West 1, and EU Ireland and Dublin, Ireland region. And we look to expand additional regions in the near future. So with that, I'm going to turn it over to Mas Kubo, who's going to walk us through a demo of AWS Backup.
Thank you, Jody. All right, my name is Mas Kubo, and I'm a product manager for AWS Backup. And I'm going to walk through the console and show you how easy it is to create a backup plan, assign resources, create backups, restore backups, and view your backup and restore jobs. So let's start out by creating a backup plan. When you first go to the AWS Backup console, you'll be brought to this dashboard view where you can see an overview of the service as well as a button to create a backup plan. When creating a backup plan, there's a few options for getting started. You can create a backup plan based on an existing template, and there are predefined templates here for you to choose from if you want to start from these. You can also build a new plan from scratch and define all of the configurations yourself. And you're also able to create a backup plan based on a JSON expression downloaded from an existing plan. This is a great way to share backup plans with other accounts across your organization or with anybody that you want to share a backup plan with, and that will pre-populate the configurations for a backup plan. I'm going to create a backup plan from scratch in order to walk through each of the configurations within a backup plan. So you start out by naming your backup plan. I'm just going to call this one Backup Plan X. And then you define a rule. So you'll give the rule a name, something like daily backups. And in each rule, you specify the frequency of the backup window, the life cycle, and the backup vault, as well as the tags. So let me walk through each of these. So in the schedule, I'm creating a daily backup rule here. So under the frequency, I'll choose daily, but there's also the option to choose every 12 hours, weekly, monthly, as well as a cron expression, which allows you to fully customize the timing as well. So I'm going to select daily here. The next setting is the backup window. This is the window within which the backups jobs are started for the resources that are assigned to this backup plan. There is a default setting, but you can also customize the backup window as well. So currently it's set to be 5 a.m. UTC time, and the window lasts for 8 hours. But you can change this to be whatever is according to your requirements. So I'm just going to stick with the default window for now. And the next setting is under the life cycle. So here you can specify when you want a backup to be transitioned to cold after it's created and when you want it to expire. So in this case, I'm going to set it to transition to cold after 1 month and then to be expired after 1 year. You then specify the backup vault. So this is the vault that the backups that are being created according to the schedule are stored in. When you first use AWS Backup, there is a default vault already made available for you. And so you can just select that, or if you want to organize your backups into multiple vaults, you can also create your own vaults. I'm just going to use the default backup vault for now. And then finally, you can specify tags that are added to backups when they are created automatically. So that's an option as well. For example, you might want the backups themselves to be tagged with backup rule daily backups. Once you've added the tags, then you can also optionally tag the backup plan itself for organization reasons. And if not, then you can go ahead and create a plan. When you click Create Plan, you'll be brought to a summary view of your backup plan, where you'll see the rule that was created. And you can add additional backup rules to your backup plan as well. The reason for that is you may want to have within a single backup plan multiple rules that do something like daily backups retained for a week, weekly backups retained for a month, and monthly backups retained for a year. So the idea is to enable you to fully customize your backup plan schedule and retention periods according to your backup requirements. Once you have your backup plan, then the next step is to assign resources to your backup plan. And by resources, I mean your EBS volumes, RDS databases, DynamoDB tables, etc. So you do this by adding a resource assignment. So let's go ahead and assign some resources. You name a resource assignment. So for example, if you wanted to assign all of your resources associated with application A, then maybe you would name this application A. Next, you specify the IAM role that AWS Backup is assuming when it is performing operations on your behalf. In this case, creating backups, as well as deleting them according to the retention periods that you set. So there's an option to just use the default role. This is a role that will be created on your behalf by AWS Backup, and it includes all of the permissions that are necessary for AWS Backup to create the backups on your behalf. You can also define your own IAM role if you want to as well, and select that one. For now, I'm just going to use the default role. If it doesn't already exist, AWS Backup will create it, or if it already exists, then it will use the default role that has already been created for you. All right, so I'm going to leave this at default role. And then to assign your resources, there's two different ways to do this. You can do it by tags, which means that any resource, any EBS volume, DynamoDB table, etc., that has this tag will be assigned to this backup plan. And the other option is to add resources according to their ID. So let's do both. So here's an example of tags is you might have your resources tagged with application names, such as application A as an example, or you might also have them organized by department. And then you can also assign resources based on their ID. And when you do that, you can select the resource type. You'll see the list of supported supported services here, and then the console will automatically find all of your resources, and you can choose that. You can also type it in directly, but this makes it easy for you to find it and select that. So once you've listed all of your resource assignments, then you can click on Assign Resources, and you'll be brought back to the backup plan description page. So here you can see the backup rule that we created and the resource assignment here. So the resources that we just assigned to this backup plan will now be backed up daily and retained for a year and life cycled to cold storage after 1 month. So when you first use AWS Backup and you come to the protected resources view, you won't see anything listed here because resources show up here when they have been backed up by AWS Backup. So we just assigned resources to this backup plan X, but that backup plan schedule hasn't run yet, so those resources won't show here. I have some listed here because I've done some backups. But what you can do though from this page is create an on-demand backup. So outside of the automated scheduled backups of your backup plan, if you wanted to create a backup immediately of a resource because you're about to do some update and you may want to be able to roll back to the previous state, then you can create a backup immediately as well. So if you click on this button, then you'll be given the option to specify which resource you want to back up, which looks a lot like the resource assignment. So, and you'll see a list of tables or volumes, etc., what have you. So you can select the resource that you want to back up. You can specify a window if you are okay with the backup happening within a certain window, or you can have the backup job be initiated immediately. Just like the backup rule, you specify a life cycle. In this case, you'll notice that the transition to cold storage is made unavailable. That's because, as Jody mentioned, the feature of transitioning backups to cold storage is supported by EFS file system backups only for now. And all other resources, all the other resource types doesn't support it, but they still do support the expire retention rule. So if I select EFS up here, you'll notice that the feature for transitioning to cold storage is then enabled. So let me go ahead and set the lifecycle policies here. You specify the vault that you want this backup to be stored in and the role that AWS Backup will assume in order to create this backup. You can also optionally add tags to this backup when it's created. So let's go ahead and create this on-demand backup, and you're brought immediately to the backup jobs page. So in this tab, you can see a list of all of your backup jobs, when they were created, what type they are, the resource that's being backed up, etc. You can filter and search. You can look across different time horizons and also set how many jobs you want to view on a single page. And then you can quickly also switch over to seeing a view of your restore jobs. Let me expand this to be over 30 days, and you can see there a history of some of my restore jobs. So this was the backup that I just created for this file system ending in 946. You can see now that it was just completed. So when I come over to protected resources, you'll be able to view the backups that were created for according to these jobs, and also be able to view the resources now in this protected resources page. So if I search for EFS file systems, you'll see that resource listed here. And if I select here, I can see all of the backups that have been created for that resource. And this is also how you would go about performing a restore, which is the next operation that I want to demonstrate here. So we just created this backup today. And so if you want to perform a restore, you find the resource that you want to restore, select the backup that you want to restore to, and select restore. Now, when you select restore, you'll be brought to a page that lists all of the configurations options that are necessary for performing a restore. keep in mind that when you're performing a restore, you are creating a new resource. So in this case, we will be creating a new EFS file system on your behalf based on the backup that you selected. The restore settings are different depending on what resource type it is. So in the case of an EFS file system, you can either restore it to as a directory in an existing file system, as a new directory in the existing file system, or you can create a new file system, in which case you can also set the performance mode and whether it's encrypted or not for that new file system that's being created. The settings will be slightly different for EBS, where you will specify the volume size and the throughput for that volume, etc. And it's also different for DynamoDB. The console automatically shows you the configurations that are required for that resource type. Once you've configured the restore, similar to creating a backup, you also, again, specify a role for AWS Backup to assume when performing this restore, and then you select Restore Backup. Similar to creating a backup job, in this case, you're brought to the Restore Job view, where you can view the status of that restore. So we've gone through creating a backup plan. We've assigned resources to that backup plan. We've created an on-demand backup. We've done a restore. I've shown you the view of the backup and restore jobs. The last piece that I want to show you here is creating a backup vault. I think that there's going to be a lot of use cases where you'll just want all of your backups to be in a single vault, and that is sufficient for you. And so there's the default vault that is created on behalf of all customers and is available when you first start using the service. But if you do want to organize your backups into multiple vaults, you can create your own. So let's go ahead and look at what that process looks like. You can name your vault, of course. Let's call it Backup Vault B. You specify the encryption key that is used to encrypt the backups that are stored in this vault. Keep in mind that this encryption key applies only to the resource types that support AWS Backup Encryption, which at launch includes EFS file system backups. All other resource types, such as EBS volume, snapshots, RDS instance snapshots, etc., they also support encryption, but the encryption key is that's used to encrypt the snapshot itself is the same key that is used to encrypt the source resource. So the key that's used to encrypt the EBS volume will be used to encrypt the snapshot that is created from that volume. So again, the encryption key specified here at launch applies to EFS file system backups that are stored in this backup vault. There's a default key that you can use, or you can also specify a key that you have created via KMS. And then you can also tag your backup vault for organization purposes. So let's go ahead and create this backup vault. Once the backup vault is created, you'll see that there's no backups listed here, but as backups are created by a backup plan or via on-demand backups, and they are pointed to this backup vault, you'll see them show up under backups in this detail view. The last piece of a backup vault is the access policy. So this is similar to an S3 bucket policy, where you're able to define who can perform what actions on any backup that is inside this vault. So for example, you may want to prevent anybody from deleting a backup from this in this vault, except for AWS Backup on your behalf according to the retention period. In other words, only the retention policy is allowed to expire backups. Nobody can come in and manually delete a backup. So you may want to set that policy as a security measure. You can also specify specific users who can take certain actions on the backups in this vault, etc. So the way you would do that is by simply, similar to any other access policy, simply typing in your access policy here. And there's the standard policy generator as well that helps to create these for you. And so with that, that completes the demo. This is that's a summary of all of the major functions and operations that you can do within the console. And with that, I will open it up.
Thank you, Moss, for the demo. And with that, I want to thank everybody for attending today. We look forward to helping you get started with AWS Backup. And with that, I will turn it over to questions.